Calculus Made Simple and Interesting by Anil Kumar. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss a very important question based on related rates of change. Here, we'll see how do we find the rate of change of a shadow. Now, in our playlist, we have many examples, different application questions where we are trying to find the rate of change of shadow. In some, a person is moving away, in some, person is moving towards. In a video, we also have a person walking on the other side of the road, a person dancing on the floor, and here is something where we are seeing the shadow from the lamp when something is dropping. So that is slightly different approach than others which you have watched so far. So I'd like you to understand how do we solve such questions, and then here is a practice question for you. Once you understand, try to do a similar question just to practice it out. So let's understand the question and then we'll take the solution as we normally do in our videos. Well, in case you want to learn from me, feel free to send an email on globalmathinstitute@gmail.com. The question here is: a ball is dropped from a point 20 meters above the ground so that it will land 12 meters from the base of 20-meter lamppost. At what rate is the shadow of the ball moving along the ground 1 second after the ball is released? Extremely important question. So let's try to make a diagram and then find the equations which can help us solve this particular question. So we are given that, let's say this is the ground, okay, and two things are happening here. One, there is a stationary lamppost. Okay, so that's the light, right? So the lamppost is 20 meters, and there's a ball which is dropped 12 meters away from it. So let's say that the ball is dropped somewhere here, and this distance is 12 meters. So it lands 12 meters from the base of the lamppost. Now, as the ball comes down, you'll see the shadow of the ball. So let's take an instance when, let's say, shadow is something like this, right? So let's say the ball is here, right? So at this time, the shadow will fall on the ground at that particular point, and let us say that this distance is x, right? So the total distance from the base where the shadow falls will be 12 plus x. Make sense? So that is what is given to you. And we need to find at what rate is the shadow of the ball moving along the ground 1 second after the ball is released. Okay, we don't even know what is the height of the ball. So we need to also find the height of the ball after it is released. Perfect. So that is also to be found. Now, which formula can you apply? Well, those of you who have done a little bit of physics can surely write down the formula. S equals to ut plus half gt squared. Well, so the formula we could write in this case height of the ball equals to initial velocity into time, or we should say initial height minus half. G is acceleration due to gravity and t square. So that is the formula. Now, sometimes this formula is given to you, right? So we know that the ball has been dropped from the height of 20 meters. So at any instance, let's say this is the height of the ball, we'll say let the height be y for us, okay? So the formula will be h equals to, let's say instead of height, we'll use, let's say this point here, height is y for us. So let's say this point is y above the ground. So at any time y is less than 20 meters, we can say y is equal to 20 minus the value of g is 9.8 meters per second, but for our calculations, we'll take 10 meters per second square. Okay, acceleration due to gravity. Actually, it is 9.8, but we'll take 10 meters per second square for easier calculations. Understand the method, okay? So 20 minus half of 10 t square. So at any instance, the height, which we are writing as y, equals to 20 minus 5t square. So we want to know the height rate of change after 1 second. That means if I put t equals to 1, then I get the value. Let me cite y1 equals to 20 minus 5 times 1 square, which is 15. So it is 15 meters above the ground. Let's say this point here, right? Let us say this point here is 15 meters when after 1 second, let's say. So that is when we want to figure out what is the rate of change of the shadow. So at what rate is this point moving? So you can see as the ball falls, it will move towards the left. That means we are expecting a negative answer, right? Length of the shadow is decreasing. Perfect. Makes sense. Now, we now understand after 1 second what is the height of the ball. How do we find the rate of change? So now the question is, how do we relate x and y? So what we have here is x is length of the shadow and y is height of ball. At any instance t, since it was released, right? Okay, so well, I have very less space, so I'm just giving you a description, not writing everything down. Great. So we know this. Now, how do we relate it? We can see similar triangles, right? So, and the ratios will be constant. So if you look at a big triangle and the small triangle, so you can say that x over y, let me write this relation, x over y is equal to, so x over y. So I'm looking at the triangle, which is right here, and the big triangle, right? So big triangle, x corresponds to 12 plus x over 20. So now from similar triangles in this situation, we have an equation, right? Okay. So from here, we can find what x is. So x is, let's rewrite, bring them all together. It'll be easy for us, right? So let's cross multiply. So we have 20x equals to 12 plus x times y. So we have 20x equals to 12y plus xy. So we can bring xy to the left side and then isolate x, right? So we have 20x minus xy equals to 12y. And from here, we can write what y is, right? X is. Taking common x, right? So we have here, let me do it this place. So if I take x common, I get 20 minus y equals to 12y. Or x is equal to 12y divided by 20 minus y. Makes sense? So I just squeezed it in. However, it looks, you know, good to understand. So what we did is we found how x is related with y. So now we can find the derivative and find rate of change of shadow, which is x. So dx dt is what we'll find. We'll definitely get into an expression dy dt also. So since we know that y is 20 minus half of 10t square or 20 minus 5t square, let's find dy dt from here. So differentiating this particular equation, we get constant is 0 minus 10t. So we get an expression for dy dt which is minus 10t. And clearly from here we can find dy dt when t equals to 1 as minus 10. So we have that expression also. Correct? So we have our equations to work with, right? So you know what x is, you know what dy dt is, and now you can actually pause the video, write down the answer. Perfect. Let me now thank all my viewers and subscribers for watching my videos, understanding these concepts, and appreciating them. Let me also thank all those who are contributing and donating, making huge difference. You know, we have been providing absolutely free services for the last 15 years. Now we have more than 17,000 videos which are being watched over 80 countries. We need support to reach millions and to provide them with quality education. Quality education is expensive as not available worldwide. So your contribution can help us provide that. Thank you. So let's get back to the solution. So what you have learned here is how do we relate different parameters and then find the rate of change of shadow, correct? So let's take these equations on a fresh page and then work out the details. So one, we got the equation saying that x is equal to 12y over 20 minus y, correct? Just check. So 12y over 20 minus y. Second, dy dt is minus 10. When t equals to 1 equals to minus 10. Right. Another thing which we also found is that the height is 15 when t is 1, right? Above the ground. And we also found that y when t equals to 1 is 15 meters, right? Correct. So all this calculation we have done. Now what we need to figure out is what is dx dt when t is equal to 1. That is it. So let's figure this out. So we'll differentiate the given equation to find the derivative with respect to time. Dx dt equals to, apply the quotient rule, correct? So we got 20 minus y whole square. Derivative of first is 12 times 20 minus y. I have to write dy dt also, but I'll write like 20 minus y, right, times y prime, which is dy dt, minus derivative of 20 minus y, which is minus minus will become plus 1, this is minus 1, right? So we get 12y y prime. So that is the derivative of 20 minus y. So whenever you do derivative of 20 minus y or 12y, you get dy dt, correct? We have to still differentiate that with respect to time. Okay, so we get this expression. Now, you could always simplify this expression, then substitute the value. Or we can just directly substitute the value, right? Um, so, so that implies that dx dt, I'm not simplifying at present. So dx dt when t equals to 1 is equal to what? So we'll plug in the value of y as 15 and dy dt as minus 10 in the whole expression, correct? So we get 12 times 20 minus 15 times y prime, which is minus 10. We can take minus 10 common. It was better to simplify. So we'll take that minus, okay, let's write down minus 10 plus 12 times y is 15 times minus 10. Makes sense, right? Okay. Divided by 20 minus 15 whole square. There was no harm in simplifying this since, y prime we could have factored out, right? It was the easier calculation. Anyway, now we'll just plug in the values and say what is dx dt, the rate of change of shadow when time is 1 second. Okay, 1 second. So let's calculate. So we get 12 times 20 minus 15 is 5. So we get 12 times, this is 5 times this, which is minus 5 times 1050. Is it okay? Okay. Now plus, and that minus makes it minus. We get 12 times 15 times 10 minus. So I've made minus here. So 12 times 15, 12 times 5. So let me put 1 0 here. 12 times 5 is 60. 6. 12 times 1 is 12 and 6, 18. Correct. Divided by 5 square, which is 25. And that gives you minus 60, 100 minus 1800 over 25, right? So which is minus 2400 over 25. 25 times 4 is 100. So multiplying by 4, we get 96. The units being meters per second, right? So that is how we are going to solve this particular question. Is that clear to you, right? So basically, we isolated x in terms of y. We found the derivative of y with respect to time. We also found that t equals to 1, what is going to be the height of the ball? And so we had everything needed to get the answer. So finally, we can say that 1 second after, the rate of change is minus 96 meters per second. So it is decreasing, right? When it hits the ground, the shadow will be 0, correct? So that is how we can actually answer such questions. I hope it makes sense. Feel free to write a comment, share your views. If you like and subscribe to my videos, that would be great. And in case you want to learn from me directly, send an email. We can be part of your success story. And don't forget to answer a related question. So in the related question, the only thing is the units are different, right? So you can take the value of g as 32 feet per second square, correct? Same equations will apply. And in this case, you see we have given you the height of the ball also. So it is much simpler. So you can easily solve it. Perfect. Makes sense, right? So with that, we end the video and look forward to your solution to this question. You can then check with my next video, which will provide complete solution of this question also. Thanks for your time and all the best.